So let's continue, my dear friends. Till now we have discussed price index numbers, right? Now let's continue with quantity index. Now, I said you there is no practical application of this quantity index numbers in real life. They are just a bookish concept. This quantity index numbers and value index numbers both don't have much application. Okay. Now, he's telling they compare and measure changes in quantity. If you compare and measure changes in quantity, you call it as quantity index numbers. To compare and measure in changes in prices, we call it as price index numbers. So for price index numbers itself, if you interchange P and Q, you call it quantity index numbers. Like what is simple aggregate price index number? Summation of P1 by P0. Instead of P, you keep Q. You will get summation of Q1 by Q0. That is your simple aggregate quantity index number. What is simple average of price relatives using AM and GM? This is the formula. Now instead of P, I'll keep Q. You will get simple average of relatives of quantity index numbers using AM and GM. Now, here P1, Q0 you have, right? Now P and Q, let us interchange. You will get Q1, P0. P0, Q0 you have, right? Interchange, you will get Q0, P0. Next, P1, Q1 you have, interchange, you will get Q1, P1. See, instead of P, I kept Q. Instead of Q, I kept P. That's it. P0, Q1, Q0, P1. Dorbish-Bowley, it's same. Fishers, it's same. Weighted average of relatives, price relatives into weights, quantity relatives into weights. See, simply what you're doing, you're just interchanging these values. That's it. There's nothing much special in this, what you're doing. Okay. So price and quantity, you are simply moving here and you are interchanging them. Now let's see one question, not that important for examination perspective. Very rarely you will see questions in the examination. Okay. But still, let's go ahead and let's see one question. Clear example. I'm having commodity. I'm having total 3 commodities A, B, C. I'm having Q0, P0, Q1 and P1. 2, 5, 7, 2, 5, 7, 6, 2, 4, 18, 2, 24. Let's calculate Lansbury, Paschi, Dorbish-Bowley and Fishers. All the 4 index numbers, let's calculate. First, let's calculate Lansbury. What is this quantity index numbers? Be careful. Quantity index numbers. The formula will change here. So what is Lansbury formula? Summation of Q1 divided by summation of Q0 into 100. Paschi formula. Summation of Q1 whole divided by summation of Q0 into 100. Now here we have P0, P0, P1, P1. So Dorbish-Bowley, L plus P by 2. Fishers, root of L into P. That's it. Now let's calculate Q1, P0. 6 into 2, 12. 5 into 2, 10. 7 into 4, 28. Now total 20, 30, 40, 50 we have. Q1, P0. Next, Q0, P0. 2 into 2, 4. 5 into 5, 25. 7 into 7, 49. So 49 plus 29. You have 78. So Q1, P0 we got. Q0, P0 we got. Next, Q1, P1. 6 into 80. We have 108. 2 into 2, we have 4. 24 into 4, we have 96. So total is 208. Next, Q0, P1. Q0, P1, 18 into 2, we have 36. 5 into 2, we have 10. 7 into 24. We have 168. So total is 240. So all the values we got. Let's go ahead and let's apply to get the final answers. Q1 P0 50. Now Q0 P0, how much we have? 78 into 100. Next Q1 P1, we have 208. Q0 P1, we have 214 into 100. Let's get the values. Now 50 divided by 78 into 100. It is 64.102. 208 whole divided by 214 into 100. It is 97.196. So Torbage Bowley 64.102 plus 97.196 whole divided by 2. So let's get it 64.102 plus 97.196 whole divided by 2. 80.649. So this is Torbage Bowley. Let us take Fisher's. Root of L into P. Root of 64.102 into 97.196. Let's get the value. 64.102 into 97.196 under root 78.93. Okay. See, there's only one question in ICMA on quantity index numbers, and this is that question. There's no other question on the base of quantity index numbers. Simple? Yes, sir, simple. Next, let's proceed further. After quantity index numbers, we have something called as value index numbers. What is this value index numbers? There are three formulas for value index number. First, there are two formulas for value index number. First formula is price index number into quantity index number. Second formula is summation of P1 Q1 divided by summation of P0 Q0 into 100. These are the two formulas what we have for quantity index numbers. Now, sometimes, my dear friends, we ask you to calculate value ratio. What is this value ratio? Value ratio is the same formula. You will not multiply with 100. Okay. Now, value index number will be current year price into current year quantity divided by base year price into base year quantity. Okay. That is called as value index number. First, it can be price index number into quantity index number, or summation of P1 Q1 by summation of P0 Q0 into 100. So I hope value index number is clear. Now, when we solve some sums in next session, there we will see sums on value index number. Okay. Well, there are some good sums in ICM material and some previous year questions which we need to solve. When we solve them, we'll go ahead and we'll understand the value index number. Next, purchasing power. How will you calculate the purchasing power? Reciprocal of index number will give you purchasing power. Okay. Say for example, index number is 157. So what is the reciprocal of 157? 1 divided by 157. And don't forget to multiply with 100. 0.636. Okay. Now what does this 0.636 mean? How will you interpret this purchasing power? It says, if in base year the price is 0.636, then in current year the price will be 1 rupee. That's how you will interpret. If in base year the price is 0.636, then in current year the price will be 1 rupee. So that's how we interpret purchasing power. Basically, it's an economics concept. Okay. Now, once again, I'm repeating. If index number is 157, purchasing power will be 0.636. So how will you interpret this 0.636? If any commodity price is 0.636 in base period, it became 1 rupee in current period. Means you are doing reciprocal of index number. See, if you want, you can do current year by base year into 100. You will get the same answer again. Okay. Something which is 63 pies in base year, it became 1 rupee now. That's how you are going to interpret this purchasing power. Again, you don't have any questions. Only one question you have in ICM method on purchasing power. Next, cost of living index. See, I said, in our country, we'll be using PASCHI methods or Lasperi index number, right? That's the reason this cost of living index using aggregate method, it is Lasperi method formula itself. Let you call cost of living index, or let you call index number which is used in our country, or Lasperi index number, everything is same. Okay. One more thing. Simple average of price relatives. Simple average of price relatives also gives you the same answer. Last penny index number, cost of living index, simple aggregate price, simple average price relatives. All the three things will give you the same answer. It asks you an MCQ. Okay, cost of living index is also called as last penny index. Okay, now cost of living index using family budget method, very olden days he used to ask this. You'll simply use this formula, summation of price relatives into weights by summation of weights. However, nowadays there is no much relevance of this formula. What is relevant is only this formula and this one. Okay, purchasing power is reciprocal of index number. Remember this line, he'll ask in MCQ. Cost of living index is last penny index number. Okay, now we'll do sums in next session. When we focus on this, we'll go ahead and we'll do the sums. Now, we have so many index numbers, right? Which index number is best index number among all these things? Basically, they say that Fisher index number is the ideal index number. Okay, why it is ideal index number? Because it satisfies three tests of adequacies. Okay, and you know there is one more index number which satisfies three tests of adequacy. That is this one. Okay, but since here weights are not taken into consideration and here weights are taken into consideration, we call it as ideal index number. And if you remember, when teaching you geometric mean, I said you in index numbers we use geometric mean, right? Geometric mean is the best measure for index number. To see here, here I use geometric mean. Here also I use geometric mean. That's the reason most of the tests are satisfied here. Where geometric mean is used, there most of the tests are satisfied. That's the reason we say geometric mean is the best measure to construct index numbers. But I said you already, Fisher's index numbers is developed in 1950 to 60 region. No country uses this. India uses Lasperi. All the developed countries use Pasche. Nobody uses Fisher index number in real life. Only they use Lasperi and Pasche. Now, what are these tests of adequacies? Total 4 tests of adequacies we have. They say which index number is best index number. Tests of adequacies will tell you what index number is going to be the best index number. So total 4 tests. What are these 4 tests? Unit test, not your unit test, it's a different unit test. Time reversal test, factor reversal test, and circular test. Okay. This circular test, my dear friends, it's an extension of time reversal test. Next, this time reversal test and factor reversal test, both are given by Fishers. Okay. This factor reversal test, how will you get? If you multiply P01 and Q01, you have to get P01. That is called as factor reversal test. Now, what is this P01, Q01, P10? Now, if you see, my dear friends, all the index numbers what we have calculated till now, all index numbers that we studied till now are P01 or Q01 or V01. This is what are the index numbers what we have studied. If you write current year divided by base year into 100, they are called as 01. See, you will read it in reverse. Okay, 01 means not base year by current year. 01 means current year by base year. You have to read it reverse. Okay, 01, no, you will read it. P01 means current year upon base year is called as P01. Okay. Q01 is called as current year upon base year. V01 is called as current year upon base year. You know, in real life, how they'll write? They'll write LP01. Now, what do you mean by LP01? LP01 means Lasperi price index number, which is current year price divided by base year price into 100. Okay. They'll write LP10. What do you mean by LP10 in real life? You know, they say Lasperi purchasing power index number, they tell LP10. You'll learn this in your CF angle, don't worry. Okay, that is 1 by last query price index number. Or you'll write base year price by current year. You will interchange 0 and 1 here. 0 and 1 will be interchanged. Okay. So this is last query purchasing power index number. This is last query price index. Okay. So if you do P10 or Q10 or V10, formulas will change. 0 and 1 you'll interchange. Okay. However, not that important for examination, just for your understanding. 0, 1 means current year upon base year. This is important because many times in MCQs he asked this. P01 means current year upon base year. P10 means base year upon current year. It will be reverse. Okay. Now we understood what is 0, 1, what is 10. Now, what does factor reversal test say? Factor reversal test says if you multiply price index number and quantity index number, you have to get value index number. That's what factor reversal test says. If you want, you can check. Fisher's price index number, Fisher's quantity index number. What is Fisher's price index number? Root of P's summation of P1Q0 divided by summation of P0Q0 into summation of P1Q1 whole divided by summation of P0Q1. Fisher's quantity summation of Q1P0 by summation of Q0P0 into summation of Q1P1 whole divided by summation of Q0P1. You see here there are few things what I can cancel. P1Q0, P1Q0 I can cancel. Next, still P0Q1, P0Q1 I can cancel. Now don't say, sir, you said summation is there, you can't cancel. See, whole expression only I am cancelling. Okay. Now, P1Q1 into P1. Summation of P1Q1 whole square. P0Q0 into P0Q0. Summation of P0Q0 whole square. Square root cancel. What is left? P1Q1 whole divided by P0Q0, which is your value index number. See, this test is satisfied only for Fisher's. Fisher's price index number into Fisher's quantity index number will give you value index number. Unfortunately, my dear friends, this factor reversal test is satisfied only by Fisher. He gave this index number, only this fellow satisfies this index number. Okay, nobody satisfies this index number. This factor reversal test. Who will satisfy? Only and only Fisher will satisfy. Right? Now, unit test. What do you mean by unit test? What I said, you index number should be unit-free measures. It's a relative measure, right? So, given index number, if it is unit-free measure, you will say this test is satisfied. Okay. This tells also, my dear friends, it is satisfied by everybody except simple aggregate. Simple aggregate does not satisfy this test. Now, two tests I guess you can remember: unit test and factor reversal test. Unit test, given index number should not have any units, but simple aggregate and index number will not satisfy. If you want, I'll show you the proof, but that's not that important. However, you can see. How will you get simple aggregate price index number? Tell me. Simple aggregate price index number will be summation of P1 by summation of P0 into 100, right? Yes. I'm having two commodities, wheat, milk. Current year price, base year price. Current year price is 70 rupees per kg. Here it is 110 rupees per liter. In base year, it was 30 rupees per kg. Here it was 70 rupees per liter. Now, what is the total of current year price? Can you tell me? What is the sum of current year price? And what is sum of base year price? Insect is roaming. Don't tell it is 180 rupees. Don't tell it is 100 rupees. You will be wrong. How can you add kg and liter? How can you'll write A plus B is equals to AB? Nonsense. How can you do this? How can you add 70 per kg and 110 rupees per liter? You can't add. Okay. It will be kg liter. Means your units are not getting cancelled. Okay. That is the reason we say simple aggregate index number does not satisfy unit test. Want you can go out and check all the index numbers. Units will get cancelled. Okay. However, this is a little higher level concept. This is, and this concept detailedly you learn in CA inter, when to cancel units, when not to cancel units. Okay. Now I hope unit test and factor reversal test both are clear. Unit test, given index number should be unit free measure. Factor reversal test, it is satisfied only by Fishers. Food will not satisfy, simple aggregate index number will not satisfy. So I hope unit test and factor reversal test you can remember. Now what is time reversal test? You are doing time travel. If you do P01 into P10, you have to get 1. P01 is current year by base year. P10 is base year upon current year. Both will get cancelled. You will be left with 1. And then you will say that time reversal test will be satisfied. You know who will satisfy this time reversal test? Simple aggregate index number will satisfy. Simple aggregate average of price relatives using GM will satisfy. This also using GM will satisfy. And last 3 people will satisfy. Okay. This you need to remember, my dear friends, because it is important for exam. The whole table is important. To see in your ICM material, there are 10 to 15 questions on percentage to index number conversion. There are 10 to 15 questions on this concept again. Okay. So only these 2 concepts alone take somewhere around 20 to 25 questions. You need to remember this entire table. See, unit test and factor reversal test is simple. Circular test is also simple because only 2 people will satisfy circular test. Only thing what you need to remember is factor reversal test. Okay. Now circular test. It's an extension of time reversal. You are doing goal. In circular test, what you are doing? You are going from 0 to 1. You are going from 1 to 2. You are coming back from 2 to 0 again. Goal you are doing. Okay. That's what is a circular test. Okay. In circular test, P01 into P12 and P20 must be equals to 1. So only 2 people will satisfy simple aggregate and a simple average of price relatives using GM. So nobody will satisfy these tests. Okay. Now, what is important? You need to remember this whole page what I have given over here. Direct questions will be asked. Okay. No numerical questions will be asked on this concept. Okay. Only theoretical questions will be asked. So make sure you will remember this whole concept what is given over here. Test of adequacy. Next. Now all major concepts in index numbers are completed. We are left with questions to solve. The more questions we solve on index number, the more better it is. However, there are 3 concepts what are pending now. Base shifting. Next, time splicing. Chain index numbers. Let us understand these 3. They are very simple. There's nothing complication there. Base shifting. Now, what is this base shifting? Earlier, my dear friends, I said you, our Indian government used to follow 1980 as a base year. Now, in 2016, I guess, they have changed the base year from 1980 to year 2000. Okay, that's what they have shifted the base. When base becomes too old, what we'll do is that we'll go ahead and we'll shift the base. That is called as base shifting. When you join 2 index numbers together, we call it as time splicing. Okay, like see here, say for example, I'm having year 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Original price index. Original price index. It's given somewhat like this: 100, 104, 106, 107, 110, 112, 115, 117, 125, 131, 140. This is the original price index. Can you tell me for original price index what is base year? Obviously, sir, 2000 is base year because base year index number starts with 100. Okay. He's asking shift index to 2006. Now he's asking you to shift the index to 2006. How will you shift? Obviously, we know base index number starts with 100. So here in 2006, index number starts with 100. Now see how the base shifting happens. When it is 115, it is 100, right? If it is 117, how much it will be? Cross multiplication you will do. 117 into 100 whole divided by 150. Cross multiply. 117 into 100 by 150. 170 into 100 divided by 115. There is one formula given in your ICA material. You need not remember that. So it will become 101.73. Okay. See here, one more case. For 115, it is 100. Then for 125, how much it will be? 125 into 100 by 115. 125 into 100 whole divided by 150. 125 into 100 whole divided by 150. It's 108.69. Again, same. For 115, it is 100. How much it will be for 131? Same cross multiplication. 131 into 100 by 150. 131 to 100 divided by 150. 113.91. Here also same idea, friends. 140 into 100 by 150. 140 into 100 whole divided by 150. 140 into 100 whole divided by 150. 121.73. Okay. Can you see here everywhere 100 by 115, 100 by 115, 100 by 115, 100 by 115 is same. So if I want here everywhere, I'll write the same thing. 100 into 100 by 115. 104 into 100 by 115. 106 into 100 by 150. 107 into 100 by 150. 110 into 100 by 150. 112 into 100 by 150. So can you see what's happening here? This part of the formula is same everywhere. Okay, 100 by 115 is same. You are going ahead and multiplying with respective index number. It's a simple cross multiplication. That's it. You need not remember any formula. Okay. So no need to remember any formula what is given in ICA material. Just remember the logic. It's more than enough. Okay. When you will do base shifting, when base becomes too old, you will go ahead and you will do the base shifting. Okay. It's very old concept, my dear friends. It's irrelevant nowadays. Okay, because Excel sheets we have very easily you can shift the base in nowadays. Okay. However, the other reason if you see it has been many years that this question has been asked in the examination. Till now it was not asked. From 2005, I guess they didn't ask this question in the examination. That's why I didn't include in the summary notes as well. This is called as base shifting. Now, what is this time splicing? Time splicing also concept is similar to base shifting. Time splicing means joining two index numbers. Joining two index numbers. If you join two index numbers, you call it as time splicing. Let me give you an example. Here, 2000, 2001, 2002, 2003, 2004, 2005, 2006, 7, 8, 9, 10. Old index numbers. 100, 102.3, 105.3, 107.6, 119.9, 114.2. New index numbers. 100, 102.5, 106.4, 108.3, 111.7, 117.8. Again, this also, I guess last in task only from the past 22 years. No, 24 years in task. So old index numbers and new index numbers. Still it's lying in isometric, so we have to study. If old index numbers come and join with new index numbers, we call it as forward splicing. If new index number go back and join with old index number, they call it as backward splicing. Now, what is a forward splicing? Old is coming and joining with new. Forward splicing. When old is coming and joining with new, who will change their place? Old will change their place. When old change, new is here itself. Old is coming and joining with new. New is there itself. When old is coming and joining with new will remain same, my dear friends. What will change? Old will change. How will you calculate? Simple. For 100, it is 114. Then for this one, how much it is? Cross multiplication. 119.9 into 100 by 114.2. Again, cross multiplication. 107.6 into 100 by 114.2. Cross multiplication. 105.3 into 100 by 114.2. Here also 102.3 into 100 by 114.2. 100 into 100 by 114.2. This is called as forward splicing. Backward splicing means new will go and join with old. That is called as backward splicing. Now new is changing the position. So old will remain same. Old will remain same because new is changing the position. Now again, this is the base. For 100, it is 114.2. What about 100? So 102.5 into 100 into 114.2 by 100. Next, 106.4 into 114.2 by 100. Next, 108.3 into 114.2 by 100. Next, 111.7 into 114.2 by 100. 117.8 into 114.2 by 100. Okay. So it's simple. What is this cross multiplication? So can you see base shifting and time splicing format is same? Okay. Not that important for the examination. If you don't look into this before the examination also, it's fine. I don't know, from past 20 years, 24 years, never they have asked time splicing. Time splicing means old index numbers will come and merge with new index numbers. That's called as time splicing. Or new index numbers go and merge with old index numbers. You are joining to index number. That is called as splicing. Slicing means you will cut. Splice means you will join. Base shifting, you are shifting the base from old to new. That is called as base shifting. This is also cross multiplication only. Let it be this base shifting or let it be time splicing. Both are cross multiplication. Simple cross multiplications there. Nothing much complicated cross multiplication. They are simple cross multiplications. Next. Last concept in index numbers. Chain index numbers. Again, this is also a theoretical concept. It's not a practical concept. Chain index number. That is, there's no practical application to this. You will, when you read it automatically, you will understand. So what one statistician thought, why to shift base every year So every time after 20, 30 years, what I'll do is that directly I'll go ahead and develop a concept called as chain index numbers. In chain index number, every year I shift the base itself. Instead of shifting base for every 20, 30 years, every year you shift it. So every year for current year, previous year will be the base year. You will have an accurate data, but no government wants this. Okay. They want something to compare very old with now. Okay. They'll say in 2000, your parents used to walk to school. Now you are going in bus. So we have developed. So that very old comparison people want. Immediate previous year comparison, nobody wants. Okay. That's the reason no government followed this chain index numbers till now in the world. So again, it's just theoretical concept. And you have to remember this formula. In chain index number, for every current year, previous year will be base. Okay. So chain index number formula will be link relative of current year into chain index of previous year whole divided by 100. Let us understand with an example. I'm having year, I'm having price, I'm having link relative, I'm having chain index. Now see here, how will we calculate? Year 1, year 2, year 3, year 4, year 5. 50, 60, 62, 65, 70. Now what is relative, my dear friends? Current year by base year into 100 if you do, you will get relative, right? Current year by base year into 100 if I do, I'll go ahead and I'll get relative. There's nothing here. There is no base here. So starting will be 100. So what about link relative here? 60 by 50 into 100. 60 by 50 into 100. 120. 62 by 60 into 100. Link relative current year by previous year. Because for every year, previous year is a base year. 62 divided by 60 into 100. 103.3. 65 divided by 62 into 100. 65 by 62 into 100. 104.8. 70 divided by 65 into 100. By 65 into 100. 107.6. This is link related. Now, chain index. Now, what is this chain index? Chain index will be a link relative of current year into chain index of previous year into 100. Is there any previous year here? There's no previous. There is. You can't apply this formula to here because there is no previous year chain index. So it will be 100. So here, link relative of current year into chain index of previous year divided by 100, 120. Link relative of current year into chain index of previous year divided by 100. So 103.3 to 120 divided by 100. 123.96. 123.96. Here 104.8 into 123.96 divided by 100. 129.9. 107.6 into 129.9 divided by 100. 130. Okay. So these last three concepts, what we have done, my dear friends, they are not that much important for the examination. But since they are there in ICM material, we have looked into them. Okay. So I hope index numbers is fine. We have completed all the concepts related to index numbers. Now what is pending is sums are pending. Okay. There are some 40 sums what I have selected in index numbers, okay, which covers maximum all the concepts and practical sums, because this what is it called? The concept is there where we use index numbers. What is the usage of index numbers? Like say for example, there's a concept of dearness allowance. This concept we need to learn, DA. This will be given to employees to maintain their standard of living. Instead of changing their basic salary, they'll give them dearness allowance. Again, this one is what happened to this. It's very old one. I guess 3 years have happened that I've taken this math. I've changed this now. So dearness allowance, to maintain the standard of living, if you pay, it's something which is paid to employees. That is called as dearness allowance. Okay. So that concept is there which we need to study. But that concept can be studied only with practical sums. We can't study with theoretical sums. Some 10 to 15 sums are there. Okay, in your CMA, and some previous year questions are there that also we need to take up. So there are around 40 to 45 sums which are important for us to do, that we'll do in tomorrow's session. Okay, and we will wind up index numbers. Okay, this entire week our focus is only on statistics. Next week we'll do mathematics. Okay, and that next week we'll do probability. Probability we will do, correlation we will do, correlation regression. Okay, because I said you already, these 3 chapters in statistics plus probability, these 4 chapters alone comprise of 30 marks. In 40 marks, these chapters alone comprise of 30 marks. But students, instead of focusing on this 30 marks, they'll focus on the 10 marks, theoretical distribution and correlation regression, which they'll not understand only. And theoretical distribution also, it's fine, binomial distribution, Poisson distribution. They'll always sit with normal distribution and they'll sit. And hardly they'll get 1 2 questions in the examination. Okay. So this week our strategy is to complete statistics part. Next week we'll complete mathematics, important chapters. Time value of money is already given, recorded to you. Please complete from there. I'll tell you those who haven't done. I'll tell you next week how to complete it. Okay. So next week our focus will be on time value of money is there. Next sequence and series is there. I said you some important chapters what we have to do in mathematics first. Okay. Instead of doing the differentiation and integration. Okay. So that's it, my dear friends. Balance things. We'll see in tomorrow's session.